So welcome to your pre-algebra course. This is your first video of the semester. So each of the videos will pertain to what we talk about weekly. So when we start, in this case it's week 1, everything that we discuss on Tuesday we will discuss again on Thursday and then take a quiz every Thursday. Well, the videos will support what we talk about on Tuesdays and Thursdays. So it would be a good idea for you to get in the habit of watching the videos early before class so you kind of have an idea of what we're talking about. So here are our objectives that we're going to talk about. We'll first start with standard, converting standard notation to expanded notation. So if you choose to buy the text, these would be the sections that we will discuss for this first week. So we want to talk about place value chart. Just remember where your decimal point lies. Okay? Everything in the decimal sections, tenths, hundredths, thousandths, 10,000ths, well, that's going to be later in the course. This week, we're looking at everything from the decimal point moving to the left. So we're looking at the ones, the tens, hundreds, thousands, 10,000s, 100,000s, and millions. What you also see with this is you'll see these 3 place values. Okay, that's called a period when I mentioned that in class. Okay, so you have a period and it has 3 place values that contain in a period. Looking at your place value chart, when we're talking about certain digits, so if I'm representing this 4 right here, notice that's in the ones place. The value of that is 4. The value of this 3 here is in the tens, so the value is 30. This is 200s, 1,000. The 9 represents 90,000. The 8 represents the 800,000, and the 7 would represent the 7 million. All right. Thinking about that, we start looking at standard notation versus expanded notation. With your standard notation, it's as if you see a number written as is. So 15, that's a 10 and a 5. So we're thinking about just what is that number. So that number is 15. If we have the number 88, that number is written in standard notation. 654, that number is in standard notation. 725, like we see here. 1,248, as we see here. So this 8 is in the ones, tens, hundreds, thousands. So that is your standard notation. So expanded, so you just think about the word. What does expanded mean? That means to stretch out the place values, show what each value represents in the different place values. So you've got 700s, 2 tens, and 5 ones. You are naming what the place value would be in regard to words. 1,200, 4 tens, 8 ones. Another way to show that expansion is to show the value. So if you have 934, you would have 9 hundreds plus 3 tens plus 4 ones. And just think about what that result is. Well, that result is 900. 3 times 10 is 30. 4 times 1 is 4. 934. So you're just expanding it by the number that's there. That's one group of 1,000, 2 groups of 100, 4 groups of tens, 8 groups of 1. So that's your expanded notation. So I want to write all of these that are in standard notation into expanded. So this would be 500s, there's 0 tens, and there's 8 ones. There's 2 100,000s. Looking at this one here, 2 100,000s. There's 3 10,000s. There's 5 thousands. There's 8 hundreds, 8 tens, 8 ones. So we're just representing that 2 is in the 100,000 spot. So I need to see the 100,000, the 10,000s, the thousands, the hundreds, the tens, and the ones as we expand that. Here we're starting in the expanded notation, and now we just want to write the following in expanded notation. We want to write what's in expanded into standard. So we see 2 10,000s. So we know 10,000s. There's your 2 10,000s. I need to see 3 thousands, 8 hundreds, 6 tens, 0 ones. Part B, I see 100,000. So I know that my place value is going to involve 2 periods. 500,000, 6,000s. So notice there's no 10,000, so I can put a 0. There's 0 hundreds, there's 5 tens, and there's 7 ones. So if you see either a 0 hundred or that place value skipped, then we wouldn't use that, and we would place a 0. Here I see thousands, hundreds, tens, ones. Thousands, comma, hundreds, tens, ones. So I see 3 ones, 2 tens, 6 hundreds, 4 thousands. That's writing from an expanded notation into a standard form. Please take advantage of the practice. If you're not using a textbook, or if you're not ordering or bought a textbook, then what I'm trying to do is give you some things that are online that allow you to use some of those practice items from the web. And if you need that, I would certainly encourage you to go to the links. If you're needing the more practice and you didn't buy the book, please use the link. Please use the links. If you don't score well on a quiz, sometimes it's because you didn't do the practice. So I would encourage you to keep a notebook, and I would encourage you to listen to the videos and work some of the problems with me. All right, addition, perimeter, estimation with sums. So I'm not going to go into standard way to add. You're familiar with that. But some of the vocabulary with addition, you're going to hear things called sums and add-ins and associative and commutative and additive identity. Those are all dealing with addition. Now, if I take 1,521 and I want to add 348, now there are different strategies to adding, but what I would like for you to do is use what we call front-end estimation. So if I give you 78, 49, 31, and 85, and I want you to add those up, well, I just want you to use front-end, which means I want you to focus on these values here, okay? So you can say that that's 70, 40, 30, and 80, and you can add those up, and that's going to be 11 and 11, so that's going to be 220. So that would be 110, and this would be 110. So there's your 220. That's just an estimate. And you could also write the 78, you could look at the front end and then look to the right and do a round. So we could say, well, 78 is close to 80, 49 is close to 50, 31 is close to 30, and 85 is close to 90. And you can add those up to get 130 and 120, which would give you 250. So you see you've got a range there between 220 and 250 a range estimate. So again, when you see something like 437 plus 529, looking at that front end, I'm just saying 400 plus 500 gives me 900. You want to work with easy numbers when you're working with estimates. So front end estimation, the 1,521, 348. I'm going to say that that is, you can look at the front end here and say that that's 1,000. The front end here, you can say that's 300. So that would be 1,300 as a result. And that would be your low end. Here we've got 3,338, 271. These are all going to produce a low end when you look at the front end. 3,338, we would say 3,000. 271, we say 200. We know on the low end it's going to be 3,200. So if we have 10,120, we could say 10,000. 12,989, we could say 12,000. 5,738, we could say 5,000. So this is 22, this will be 27,000 on the low end. And then 45,879, we could say 45,000. And 21,786, we could say 21,000. So this would be 66,000 as an estimate on the low end. Find the perimeter of the following. Remember that perimeter is what you're adding all the way around. So we start with 3 and add 2 and add 4 and add 3 and add 7 and add 5. I just went clockwise. And so that would be 5, that would be 7, that would be 12, and that would be 12 plus 12. So 24 centimeters would be the perimeter. Remember, perimeter is you're adding those values together, adding those sides. In this case, it looks like I'm missing 2 sides. However, I know that this side is 3 4/10 and this side is 3 7/10. So if I add 3 7/10 and 3 4/10, I'm going to get 7 1/10. Well, that's what this is. Here, I know this is 3 1/10 and 3 8/10, so I know that's going to be 6 9/10. So if I want the perimeter, I'm going to have to add everything. And I'm just going to work this way. 7 1/10, 3 1/10, 3 4/10, 3 8/10, 3 7/10, 6 9/10. So 16 tenths, 12 tenths, 2, start that over there. So that's 16 and 8, 24, 25, 30. So 1, 2, 3, 4, 5, that's 15, 15 and 13, so what's 28? So that's 9. Okay. So 28 centimeters as our perimeter. All right. Look here, we would say, I'm going to start with 5 and I'm going to work my way around. So 5 plus 4 plus 9 plus 7 plus 7 plus 8. So there's 9, there's 16, there's 15. So that's 20 and 11, so there's 31 and 9. So this would be 40 units as the perimeter. Another perimeter, we would say, I'm going to start at 6 and work here, go to 3, go to 11, 9.5, and 6. So 6 and 18 is 24. Plus 6 and 3 is 9, so that's 33. Plus 11 is 44. And 15.5. That's 9.5 and 6, so 15.5. So 59.5 centimeters. So that's finding perimeter. That's using addition strategies and front-end estimation. So let's look at subtraction. When you're thinking about vocabulary, that should be subtraction. When you're thinking about vocabulary with subtraction, you're thinking difference, the minuend. So a lot of times people say, well, 8 minus 3. Well, 8's the minuend, 3 is the subtrahend, and 5 is called the difference. These are more of your formal names. And then we've got different ways to do subtraction. We can do our standard algorithm. We can look at adding up, or we can do compensation. These are different strategies. However, I want you to work with, I'd like for you to work with your front-end estimation ideas. So if you got 57, take away 29. Well, let's go with 50, take away 20. So about 30 would be an approximation there. 80, take away 24. Well, I'm just going to say 80, take away 20. So that's going to be approximately 60. 145, I'm going to say 100. 78, I'm going to say 70, and I'm going to subtract, and I'm going to get about 30. So that's your, remember, that's your low end, okay? $612, I would say 600. 493, I could say 500. I could round up. 493 is close to 500, so I'm still using the front end of that. So that difference would be about 100. The 4,976, I could say that's about 5,000. 2,848, that's about 3,000. And the difference would be about 2,000. Well, 4,976 minus 2,848, the actual difference is 2,128. So going with 2,000 is a really good estimate. Let's look at F, 12,000. Let's go 12,406. Let's just say 12,000. And then 9,818. Let's just go with 10,000. So that's about 2,000. Notice I keep using the word about because we're talking about an approximation. And then last, we've got 45,807. Let's say 46,000. 21,786. Why don't we say 22,000? So I was kind of looking here at the hundreds and rounded that up to 46,000. The 7 rounded up the thousands to 22,000. So that would give me about 24,000. But if you take 45,879 and subtract 21,786, you're going to get just a little over 24,000. So again, that's a good estimate. So that was subtraction. So let's look at multiplication and the vocabulary with that. Anytime you hear things called repeated addition, well, especially when we're talking about order of operations, repeated addition is multiplication. Instead of adding over and over and over, we use multiplication. We can also hear things called factors. 5 and 4 are factors of 20. 5 times 4 is 20. So 20 is the product of 5 and 4. We can look at arrays. We can look at groups of. So 1, 2, 3, 4. There's 5 groups of 2. So the array would be a 5 by 2 array, which really creates a rectangle. We can think groups of, 5 groups of 2. So instead of adding those all together repeatedly, we would say, well, there's 5 groups of 2, which has to be 10. So you'll hear us use the multiplicative identity, distributive property, commutative property, associative property, dealing with multiplication. okay? Finding area when we're dealing with squares and we're dealing with rectangles. All right, so if I want you to find the product, I want you to think about using front-end estimation. So 65 and 8. Well, let's just make that go to 70, and then we'll just stay with 8. So 8 times 7 is 56, but this is 10 times bigger, so it's actually 560. 94 times 6, I'm just going to say 100 times 6, and that would be 600. 806, I'm going to say 800 times 7. Well, over here we had 8 times 70 is 560. Well, this one would be 56 multiplied by 100, which would be 5,600. 85 times 47. Well, I'll just say 90 and 50. Well, 9 times 5 is 45, and I've got 2 zeros there, which means I'm multiplying it by 10 twice. So multiply it by 10 twice was the same as multiplying it by 100, so you'd have 4,500. 96 times 20, I'm going to go ahead and say just 100 times 20. So 1 times 2 is 2. I've got 3 zeros there, which means I'm multiplying by 10 3 times. So I would have 2,000. 549, I'm just going to go ahead and say 500. 88, I'm just going to say 90. So 9 times 5 is 45. I see 3 zeros because I've multiplied by 10 3 times, which is 1,000. So what's 1,000 times bigger than 45? It would be 45,000. And then last, I see 444, so I'm just going to say 400. 33, I'm going to say 30. So 4 times 3 is 12. I see the 3 zeros, which means I'm multiplying it by 10 3 times. So these are all approximates. These are all estimates using the front-end approach. Very easy approach because you're really working with easy numbers. You're working with lots of zeros. And next we'll look at division and estimates with division. So anytime you hear repeated subtraction, well, that just means you're subtracting over and over and over. Well, that's what we do with division. Division is we just cut that down. When we're talking about dividing numbers, we have our dividend, we have our divisor, and we have our quotient. You can also think, well, 25 divided by 5, well, that's the same as 5 times something is equal to 25. So you've got a missing factor that you're thinking about. All right, so let's look at if we're going to divide using front-end estimation. Well, this is 72 divided by 6. Well, we could say 72 divided by 8. I'm just rounding the 6 up a little bit to the 8, so we would say that's approximately 9. And when we think about what is 72 divided by 6, it's actually 12, but using the estimation, I just used something, this 8, that I knew would divide 72 evenly. 56 divided by 1, well, that's going to be 56. 0 divided by 7 is going to be 0. 8 divided by 0 is what we call undefined, because I do not want 0 as a divisor, because if you're thinking about repeated addition, I'm just going to subtract over and over and over and over if I keep subtracting 0. So there's no end to that. 277 divided by 5, well, I'm just going to round that up to 300 divided by 5. And I'm thinking, well, 5 will divide 300 60 times. And then 4,521 divided by 6. So let's say, I don't know, let's say 45. Let's say 4,500. and let's divide that by 5. So that would be 90 and another 10. So that would be 4,500. Let's look at 3,219. We could say is close to 3,000, and 111 is close to 100. So what you have here is you've got 3 times 100 times 10, all divided by 100. I'm just breaking up the 3,000. Well, the hundreds will divide out, leaving you with 3 times 10, so your answer is going to be 30. And then the 7,242 divided by 24. So this one here, I'm just going to probably just round up to 800 or 8,000, excuse me, and round that down to 20. So should be 400 is my answer. And that's just an estimate. Now let's look at rounding to the nearest 10 or to the nearest 100 or to the nearest 1,000. So it's specific what I'm asking you to round to. So I'm looking at the tens. All right, so you want to look at your numbers there, and the tens place would be this 3. So this with 137, here's one way to do this until you just get, you may be really proficient with it already, but if you need some review with the rounding, you could say, well, I need it to the 10, so I'm looking at it's between 130 and 140. Well, here's 135. Where's 137 fall? That's about right there. So is it closer to 140 or closer to 130? And so we would round it to be 140. Same idea with 235. I want to round it to the tens. I'm looking between 230 and 240. Well, what's between the two? Well, that's 235. 235 is right on there. So is it closer to either one? No, it's equidistant. So when that happens, you round it up. So it'd be 240. When you have 473 and you round into the tens, you could look and say, well, that's going to be 47 tens or 470, 480. Halfway between is 475. Where's 473? Somewhere there. So is it closer to 470 or 480? We would say 470. So the idea about the rounding piece is you're just looking at the designated place value, and then you can look at the place value to the right. And if it's 5 or more, you're going to round up. So 7 was more, so that's why it rounded. That's why it rounded to 140. 235, 5 or more, so that's going to be 240. 473, well, the 3 is not, it's less than 5. That's why you saw it stay at 470. And 4 in the 684 was not rounded up, so it stays at 680. Here's to the nearest hundreds. So now you're looking at all of these places right here. 641, look at the number to the right. It's a 4. It's not 5 or more, so it will be 640. Look at 759. Look at the number to the right. Look at the 9. The 9 will round it up to 760. Look at 1,871. Look at the hundreds place. Look at the one to the right. 7's larger, so it's going to round that 8 up to 1,900. And then 9,325. Look at the hundred spot. The 2 will not round that up, so that will stay at 9,300. Okay, and then the same thing with thousands. there's your 7,000. Look to the right, it's 8. That'll round to 8,000. 8,000, look to the right, that's 4. It's not going to round it up. It'll stay at 8,000. Here's 9,000, look to the right of 3, so that will stay 19,000. 121,657, look to the right, you can see 6, so that will round to 122,000. So there's more practice with rounding. I would encourage you to go to those links if necessary. Okay, so just a couple more items to talk about. We're going to look at solving equations in context. And when you think about the vocabulary that's involved with solving equations, an equation versus an expression. So if you had like 2x plus 5 and 2x plus 5 equals 10, there's a difference here. Your equation is this one. Your expression is this one. The difference, there's no equal sign. So when you're asked to write an expression, you wouldn't have an equal sign. When you're asked to write an equation, that's when you're going to compare one expression to another expression. The solution, all that does is make the inequality a true, or the equation a true statement. Variables are your letters that are involving something that's unknown, and inverse operations are your biggie. That's the one where it's telling you you're going to do the opposite of something. So for instance, when you're solving equations using inverse operations, so x plus 12 is equal to 27. What I want you to see is, what's the operation that's given? It's addition. So what's the inverse of addition? Well, it is subtraction. So you're going to subtract both sides. Now you may want to write it like this, horizontally. That just means that that goes to 0, so you're left with x equal 27 minus 12. You're going to get 15. Now some of you may have seen it written as x plus 12 equal 27. Maybe some of you grew up seeing it, well, I'm going to subtract 12 underneath it and subtract 12 over here underneath it. This goes to a 0 pair, just like we went to a 0 pair over here. So that's x equal, and then 27 minus 12. You're still going to get 15. Just different ways to write your subtraction. All right, another one is 10 plus x equal 32. And you see the variables here, but you see 10 is a positive 10. So what we would do is subtract 10, because we want to move the term away from the variable. So to do that, we want it to go to 0. So that would be x equal, and then 32 minus 10, we would get 22. Another one is x plus 28 equals 54. Same idea. We recognize, well, what's the operation? It's addition. So we want to take the opposite, or the inverse operation. So we want to subtract 28 to both sides. That goes to 0. That's what we wanted. So 54 take away 28. And that's going to be 26. And the next one, let's look at 77 equals x plus 32. Okay, so the variable's on the right. That's not a problem. The variable can be on the left or the right. Check out your operation. You see that that constant of 32 is adding, so we're going to subtract 32. That goes to 0. X is equal to 45. Finally, we've got, let's look at 182 equals 65 plus x. See 65 is positive, so I'm just going to subtract 65 to both sides. I'm going to get 117 equals x. Then we also have solving using inverse operations when we notice there's multiplication here. So we've got 10x equals 240. So this operation here shows multiplication. What's the inverse? That's what you're asking yourself. What's the inverse? It's division. So that's what you're going to apply. You're going to divide both sides by 10. This goes to 1x, which is what you wanted. That's that multiplicative inverse. This idea of taking 10x and dividing it by 10 is the same as taking 10x and multiplying it by its inverse. Well, that's going to go to 1x. And then 240 divided by 10 is 24. Over here, we've got 144 equals 9x. So we want to divide both sides by 9. So 144 divided by 9 is going to be 16 because there's a remainder of 0. And then we've got 1,092 divided by 14. Because it's 1,092 is equal to 14x. So we're going to divide both sides by 14. So 1,092 divided by 14 should divide 7 times. And that's going to be 98. 109 minus 98 is 11. And then I'll bring down my 2 here. And so 14, and then that should be 8. 8 times 4 was 32. So I put my 3 up here. 8 times 1 is 8, plus 3 is 11. And so it divides evenly. X would be 78. How about 715 divided by 5x? So you see 715 equal to 5x. Well, to solve for x, you're going to divide by 5. Why? Because that 5 and that x is being multiplied together. So you'll have 715. You'll divide that by 5. So that will 500 times. So now that's got 21 tens. 5 will divide 21 tens. 4 tens. So that's 20. And now bring down the 5. 5 will divide 15 3 times. So x would equal 143. So again, that was solving equations. Now let's look at exponential notation and order of operations. So with the order of operations in context, we've got a family of 4 that goes to a soccer game. Tickets are $5 each. Family of 4. We're going to get, that's going to be $20. The mom also buys a soft drink. How would you write this expression? Okay, so I didn't need to simplify that just yet, but I would have 5 times 4, and then I would add the 2 to represent. So I want an expression. So I don't want to see an equal sign. I don't need to see that. So if I was going to compute this, then I would say, well, that's $20 for the tickets, $2 for the soft drink. It would be a $22 total. But when I want the expression, that's what I'm looking for. Now, when you're solving your order of operations, notice what I did here is that I did the 5 times 4 first. Why? Because that's multiplication. Why did I add second? Because that's part of the order. The order of operations are any parentheses or brackets or grouping symbols done first. But how are you looking? Well, you're looking left to right. And I did that as well in this problem. I looked left to right, and I saw the 5 times 4 first, took care of that, then I added the 2. Next, you want to look at exponents. Well, exponents are just repeated multiplication, which we'll notice in just a moment. And then multiplication and division kind of work hand in hand, but it's whatever you see first that goes from left to right. Same with addition and subtraction. So some more thoughts here. You can see it's left to right, whichever one comes first. Addition and subtraction, multiplication and division. More thoughts about the order of operations. Okay, so let's go back to it. When we see numbers that are multiplied out, so 4 times 4 times 4 times 4, that's your expanded notation because it's written out into its factors. Well, how many factors are present? Well, we see that 4 factors are present. And what are the factors? Well, the factors are 4. And then what we have is 4 multiplied by itself 4 times. That's going to be raised to an exponent. So the base is 4, the exponent is 4 in this particular problem. Here, I've got how many 3s, how many factors are present? 4. What are the factors? Factors 3. What's the base? 3 is being multiplied by itself 4 times. So 4 is the exponent. 3 is the base. Five to the third is written in an exponential form. 5 times 5 times 5 is written in your expanded form. Well, you're looking here is just see how many factors we have. Well, we got 3 factors of what? 3 factors of 5. So 5 is the base, 3 is the exponent. When you're dealing with order of operations like this one, we see 93 minus 14 times 5. You can't just start with 93 minus 14 working left to right. You got to think, well, I need to do this first. Even though that there's no parentheses, you're still looking left to right. So that's 50, that's 70. So we would have 93 minus 70. Now I can do subtraction, and I would get 23 as an answer. 100 divided by 4 plus 4. Looking left to right, I see the division comes before addition. So 100 divided by 4 is 25, plus 4, I'll get 29 as an answer. Now I've got a parenthesis here. So that indicates that I need to do this part first. So 20 multiplied by 5 minus, well, 56 minus 16 is going to be 40. Now that I've simplified that part, I'm still looking left to right, and I see multiplication and subtraction. 20 times 5 is going to be 100. 100 minus 40 will give you 60. Okay, and then finally, below, I've got 75 divided by 5 plus 97 minus 12. I want to do this part first, which is going to be 85. So 75 divided by 5 plus 85. Well, 75 divided by 5 should be 15, and then 85 plus 15 is 90 and 10, should be 100. So that's using your order of operations. And I can make up one here. I could say, well, what's 20 minus 4 multiplied? You can use the dot as well, times 5 plus 8. Well, when you're looking at this left to right, you see subtraction, multiplication, and addition. So you're going to work right here. So that's going to be 20 minus 20 plus 8, because we needed to take care of 4 times 5. Now you're looking left to right. You see subtraction coming first. Doesn't matter. You're still going to work left to right with addition and subtraction. So 20 minus 20 is 0. 0 plus 8, you get 8 as an answer. So if you need more practice with the order of operations, you do have these practice links with the answer key. I would encourage you to look at those.